Hello, good morning students, and welcome once again to this short video tutorial on the AS level organic chemistry. Now once again I'm going to focus on a reaction that is a test for the carbonyl group, and those of you who have studied this topic are well aware that the carbonyl group, that is the C double bond O, can be tested by adding a reagent called as 2,4-dinitrophenylhydrazine, as has been shown here on the screen. And when they react together, a water molecule is eliminated and you get a condensation product as shown here, and that gives you an orange red precipitate. The exact color depends upon which particular carbonyl group you have used over here. Now you are told that this is the test for the carbonyl group, that is the test for the aldehydes and ketones. That means if you want to confirm whether your given compound contains the carbonyl group, you perform this test, and if you get an orange red precipitate, it confirms that the compound contains the carbonyl group and it can be either an aldehyde or a ketone. But at the same time, the students are told that carboxylic acids, esters, acyl chlorides, amides, etc., they do not respond to this test. So the question arises is that all these compounds, carboxylic acids, esters, acyl chlorides, amides, they also contain the carbonyl group. So why should they not respond to the 2,4-DNP test? So the reason has not been explained in the standard AS and A level textbooks. So students are simply made to memorize this fact. Now I am going to give you an explanation for the same, which is actually not included in your syllabus, but because this point has been mentioned, it becomes necessary to know that why this doesn't happen. So let's try to understand this. Now I have written down one example with carboxylic acids. So if you look at the structure of the carboxylic acid, you find that there is a delta positive charge on the carbon and delta negative on the oxygen because of the electronegativity difference. So this carbon is electrophilic because it can attract an electron pair. Now what happens in carboxylic acid, that there is an oxygen, two oxygens. The oxygen which is having a single bond, it is also having two lone pairs of electrons, and this lone pair, one lone pair, can move between the carbon and the oxygen, forming a new bond, and this electron pair moves to the oxygen, giving it a negative charge. This is known as a resonance structure. Okay, but the important point here to understand is that the positive charge on the carbon, on this carbon, diminishes. As you can see, the positive charge has moved to the oxygen and therefore it becomes less electrophilic. In other words, this carbonyl group does not behave in the same way as the carbonyl group of the aldehydes and ketones. Now you will find that same thing happens in an ester or in an acid chloride or in an amide, that the atom next to the carbon has lone pairs of electrons, and a similar phenomenon is possible, making the positive charge on this carbon less and therefore weakening this positive charge. Whereas if you consider the structure of aldehydes and ketones, then you find that the carbons which are attached to the carbonyl carbon, they do not have any lone pairs of electrons. Therefore, the positive charge on this carbon is not diminished, and therefore it shows the reactions typical of aldehydes and ketones, whereas the carboxylic acids, esters, amides, etc., they have a lone pair of electrons on the atom next to the carbonyl group, which diminishes the charge on the carbon, and therefore these compounds do not behave exactly like aldehydes and ketones, and they do not respond to the 2,4-DNP reagent test. Hope this makes it clear to you. If you have liked this video, please comment and share this video with your friends. Thanks a lot for watching. Thank you.